ranked variable and a multichotomy and also a ranked variable, as well as a ranked variable with an interval variable. They were missing, and Weary in his, as I was saying, in his text, Contributions to Correlation Analysis, provided formula that allowed you to make them calculations or to do them calculations. And in this situation, when we have a dichotomous nominal variable versus a ranked ordinal variable, the formula in this situation is defined by its or subscript dr, or being the correlation coefficient, the typical symbol used for a correlation coefficient, dr meaning it's a dichotomy against a ranked variable, and it's equal to 2 times the sum of the ranks associated with the dichotomy that's labeled as a 1 minus the number of dichotomies that are labeled 1, the sample size with respect to the dichotomy that's labeled 1, multiplied by the total sample size plus 1, and that's divided by, it's divided by the product of the number in the dichotomy labeled 0, the sample size for that, times the sample size associated with the dichotomy labeled 1, times the total sample size squared. When we're talking about sample sizes, we're talking, we've laid this out, we're talking about paired observations, okay? When we convert this into a contingency table, we're talking about the total number of frequencies across the contingency table. So it's n squared minus 1, and that's all divided by 3, and it's the square root of that denominator. So it's the square root of this particular let's say, parameter here. So what we'd like to do is we'd like to calculate this correlation coefficient in a data where we have 2 variables that are similar like this. So what I'm going to do is, let's say for argument's sake, I'm just going to create a contingency table where we have our natural dichotomy. Okay, so let's say we have our natural dichotomy. Excuse me. So down here we have our nominal variable. You're either 0 or 1 on the nominal variable. And the world rankings in this case, excuse me, the world rankings, I probably should really, let me just ignore that here. Yeah, so what we're actually going to do is let's just take our dichotomy and let's list it out in a column. Okay, so on the dichotomy, whether you've won the masters, it's either no or yes, or zeros and ones. So don't get this labeled as 0 and this is labeled as 1. And what we're going to do is we're going to take our rankings and we're going to put our rankings down here. Okay? So in this situation here, now we're going to fill in more values here. It doesn't matter. We just need some values to work with. Okay? But what we can actually see is that those that are labeled as a 0 have a world ranking. The first one has a world ranking of a 7, the next one a 5. Let's say the next 0 was ranked 20th, let's say 22nd. The next one, let's say the next person was ranked, let's say 9th, and let's maybe just leave it there. In relation to those that were ranked, that won a masters previously, their world rankings were, you can see we have an 8, a 1, we have a 2, we have a 4, and let's say for argument's sake we have another person that won the masters was ranked in 6th position. So what we've now got is we've taken the dichotomy and we've associated with the dichotomy all of the world rankings. Okay? Now, so in this situation here, no, they don't have to be evenly, we don't have to have the same sample size. Okay? Over here, the number of observations listed down here is known as N0, the number of zeros, okay, the number of observations in the first dichotomy, and over here, the number of observations over here is known as N1, and it happens in both situations that N0, in this case, N0 is equal to N1, which is equal to 5. Okay, excuse me. And in total, we have the total number of observations, the total number of these particular paired values. Well, it's how many values are over here. It's 5 plus 5, so it's equal to 10. So don't forget that n is equal to n0 plus n1. In this case, it's 5 plus 5 gives us a 10. Okay? So we basically have already nearly everything for this particular correlation formula. We have n1, the number of observations in the group that's labeled 1 on the dichotomy. We have n0, the number of observations in the group that's labeled 0 on the dichotomy. And we have n, which is the sum of all observations, which is the sum of both sample sizes, which in this case is equal to 10. The only thing that we're missing is the sum of the ranks associated with the dichotomy that's labeled 1. So actually, in this situation, we're just going to sum up these values. So we have 8, 9, 11, 15 plus the 6 gives us 21, So this value here